Welcome, my friends! In this video, we will be calculating probabilities from the normal distribution using a table. If you didn't watch my video where I introduced the normal distribution, I highly recommend you check out that video. Anthony loves to drink apple juice, and the number of ounces he drinks in a day follows a normal distribution with a mean of 100 and a standard deviation of 10. If we let x represent the number of ounces of apple juice Anthony drinks in a day, then x is normally distributed with a mean of 100 and a standard deviation of 10. Here is the distribution of Anthony's daily apple juice consumption. Let's briefly talk about some of the useful things to remember when calculating probabilities using the normal distribution. Areas underneath the curve represent probability, and the total probability is 100%. In a normal distribution, 50% of the observations are smaller than the mean, and 50% of the observations are larger than the mean. So the probability x is less than 100 is 50%, and the probability x is greater than 100 is also 50%, as 100 is the mean. Also, since the normal distribution is a continuous distribution, there is no probability at an individual point. So we can also write the previous two statements as the probability x is less than or equal to 100, or the probability x is greater than or equal to 100, and they will still both equal 50%. The probability x equals any individual value is equal to 0, such as the probability x is equal to 100. Since the normal distribution is continuous, the probability we observe any individual value is always 0. Anthony will never drink exactly 100 ounces of apple juice in a day. He might be very close, such as 99.9976 ounces, or 100.0013 ounces, but if we measure out far enough, the probability of x equaling exactly some number will be 0 for any continuous distribution. Also, as the normal distribution is symmetric, any area to the right of the mean has a corresponding equal area to the left of the mean. For example, the area between 100 and 110 will be the same as the area between 90 and 100, since both 90 and 110 are 10 units away from the mean, just in opposite directions. The probability happens to be about 34% in both cases, which you might know if you are familiar with the empirical rule. Let's look at how we can calculate probabilities like this now. Consider this question. What is the probability that on any given day, Anthony drinks more than 115 ounces of apple juice? This can be translated into the probability statement, the probability that x is greater than 115. On the normal distribution graph, we can shade the area greater than 115 to help us better visualize the problem. The shaded area represents the probability we are trying to solve for. The next step is to convert x is equal to 115 into a z-score using the z-score formula that we discussed in the last video. Z is equal to x minus mu divided by sigma. X is 115, mu is the mean at 100, and sigma is the standard deviation at 10. So the z-score is 115 minus 100 divided by 10, or 15 divided by 10, which comes to 1.5. We can create a second horizontal axis for the graph that corresponds to z-scores. A z-score of 0 always corresponds to the mean, and we just calculated that 115 corresponds to a z-score of 1.5. This tells us that 115 is 1.5 standard deviations above the mean. The probability that x is greater than 115 is equivalent to the probability z is greater than 1.5. At this stage, we need to look for z equals 1.5 in the standard normal distribution table. Now, there are a variety of different tables that you might use to calculate normal probabilities, but the one we will use looks like this. Notice it says standard normal distribution table, which is why we needed to convert to a z-score first, as z-scores relate to the standard normal distribution. The important thing is to look at the picture at the top of the table, which informs you what probability the table is solving for. Here we can see that this table is solving for the probability from the mean of the distribution up to the z-score, so the area right here. Other tables might solve for different areas, such as the probability less than your z-score, or maybe something else, so always check the picture first. The table has two columns, z and f of z. You need to search for your z-score in the z column to find the corresponding probability listed in the f of z column. Remember that our z-score was 1.5, so scrolling down, I see that 1.5 is at the end here, and the second column tells me that the probability is 0.4332. So write that number down and we will discuss what to do with it in a moment. Note that this table only goes to 3.5, and at the bottom we are given the probability you should assign if z is greater than 3.5, 0.4998 if z is between 3.51 and 3.61, 0.4999 if z is between 3.62 and 3.88, and 0.5 if z is greater than 3.89. Technically, you never reach 50%, but rounded to 4 decimals, the probabilities reach 50% when z is greater than 3.89. Okay, our table probability is 0.4332, which we said is the area from the mean up to the z-score in this area on the distribution. But we want to solve for the green shaded area, so there is one more step to get the answer. We can use one of the facts of the normal distribution we discussed from earlier, which is that 50% of the area falls on either side of the mean. 0.4332 plus the unknown green shaded area adds up to 50%, which means we can subtract 0.4332 from 0.5 to get the missing area. 0.5 minus 0.4332 equals 0.0668, which is our desired probability. If you aren't sure, you can add up the two probabilities together and verify that they do indeed add back up to 50%. So the probability that Anthony drinks more than 115 ounces of apple juice in a day is 0.0668, or 6.68%. Fairly unlikely. Let's try another one. What is the probability Anthony drinks between 88 and 110 ounces of apple juice in a day? This can be written as the probability 88 is less than x is less than 110. Graphically, here is the area we are trying to solve for, which is made up of two different sections on the graph, which I have shaded in different colors. Now, we need to convert x equals 88 and x equals 110 into two z-scores. The z-score corresponding to 88 is 88 minus 100 divided by 10, which equals negative 1.2. The z-score corresponding to 110 is 110 minus 100 divided by 10, which is equal to 1. We can add the second horizontal axis and put our z-scores on the graph. The probability 88 is less than x is less than 110 becomes the probability negative 1.2 is less than z is less than 1 if we convert into z-scores. Now we must look for z equals negative 1.2 and z equals 1 in our table. The first number we need to look for is negative 1.2 for z. But if you look at the numbers in the table, you notice that there are only positive values for z. Negative 1.2 is nowhere to be found. Whatever will we do? Well, have no fear. Due to the symmetry of the normal distribution, we can just search for positive 1.2 instead of negative 1.2, and that will give us the area from the mean down to our negative z-score instead of up to the positive z-score. The probability associated with 1.2 is right here, 0.3849. And the probability associated with 1, which is our other z-score, is down at the bottom, 0.3413. The numbers from the table are 0.3849 for z equals negative 1.2 and 0.3413 for z is equal to 1. Now back at our graph, remember that these probabilities are from the mean up to our z-score, which thankfully is the area that we're looking for. The green area is 0.3849 and the red area is 0.3413. Adding the two probabilities together, we have 0.3849 plus 0.3413, which equals 0.7262. The probability Anthony drinks between 88 and 110 ounces of apple juice in a day is 0.7262, or 72.62%. We can also go backwards and translate from a probability back into the raw score, in our case, ounces of apple juice. For example, on 90% of days, Anthony drinks at most how many ounces of apple juice? Notice that this question has given us a probability, 90%, and wants us to find the corresponding ounces of apple juice. So again, it's helpful to draw the graph. We want the value x such that Anthony drinks less apple juice than x on 90% of days. This means 90% of the time, Anthony drinks less than the value x, so the two shaded areas must add up to 90%. 50% is to the left of the mean, as that's one of the characteristics of the normal distribution, which means that the red area must be equal to 40%, so that the two areas add up to 90%. Remember that the table values tell us the area from the mean up to some value, in this case from 100 up to x. That area is 40%, so the probability we need to search for in the table is 40% or 0.4. Here we are at the table again. In this case, we have a probability, which is a value associated with the f of z column, so therefore we are searching for 0.4 in the second column instead of the first column this time. If we scroll down, we see 0.4 would fall somewhere between a z-score of 1.28 and 1.29, but it's a little bit closer to 1.28. Different teachers might have different conventions when your desired probability doesn't fall exactly in the table, but I'm fine with just taking the nearest value, which is 1.28. Now, 1.28 is the z-score associated with the number of ounces of apple juice that we want. We can add the secondary horizontal axis and plot the z-score of 1.28 on the graph, but we still don't have the value in terms of x, the raw score, or in our case, the number of ounces of apple juice. We need to convert into ounces of apple juice using the raw score formula, which is x is equal to z times sigma plus mu. We have x equals 1.28 times 10 plus 100, which simplifies to 112.8. This is the missing value for x on our graph. On 90% of days, Anthony drinks less than 112.8 ounces of apple juice. Alright, my friends, that wraps up our discussion of how to calculate normal probabilities using a table. We will be exploring many more fun and exciting statistical topics that you won't want to miss, so make sure to check out our other videos.